Hello, everyone. We're going to give it a few more minutes to make sure everyone gets into the webinar. I think people are still joining, so we'll give it a few more minutes before I begin. To get started, thank you so much for everyone joining the webinar today. My name is Amber Brown, and I am the North American Sales Director for Move Solutions. I joined the company a little over a year ago, and today we are having the webinar on bridge monitoring. So I actually originally scheduled a different webinar for today, but being born, raised, and living in Pittsburgh, after the tragedy that happened with our bridge a few weeks ago, I decided to change the webinar to bridge monitoring and how to analyze the health of your structure 24/7. I think that bridge monitoring is extremely important for many reasons. We shouldn't be driving over bridges in 2022 that can collapse. I actually saw a post on LinkedIn about that bridge collapse, and it said, "I wish Google Maps would tell you if you are driving over a poor rated bridge and give you the option to have an alternate route." And I agree with that 100%. I think now, knowing that the infrastructure is aging globally, we should feel safe driving over bridges and not have to worry that there could be a problem while we are going to work in the morning or driving our kids home after school. It just shouldn't be happening in 2022. And especially with Move Solutions, we have the technology to monitor the health of that bridge from your home, from your office. There's just no excuse why these bridges should be collapsing. So to tell you a little bit about Move Solutions, who are we? So we are the global leader in dynamic wireless monitoring solutions. We are a very young and dynamic company. We are about 5 years old, and we develop systems for structural health monitoring. So we have innovative sensors. We also have advanced algorithms that are able to deliver the condition of your structure to you 24/7. We originally started in Italy and quickly grew through Italy, throughout Europe. And as you can see next to the world, we are global. We are in North America, we are in South Africa, Australia, Russia. We're growing rapidly because our technology is perfect for structural health monitoring. We offer a dynamic system that is unlike any other. We design all of our devices from start to finish, ensuring that they are the highest quality and have the highest reliability possible. All of our products are completely wireless, they're battery powered, and that ensures that there's a very easy and simple installation. We have 4 sensors total. We have 1 static sensor and 3 dynamic sensors. We have 3 communication devices, a cloud platform, and we have 12 global distributors, and we are adding to them monthly. We're growing very fast. So today in the webinar, I really want to show you an overview of our system, take you quickly through each sensor, how they work, and then what we can do with our sensors to monitor the bridges. So first, why do we want to monitor a bridge? It seems obvious, but maybe we're not sure. But as you know, structures are dating, they're getting old, and perhaps you need to monitor the health of that old structure. They're also degrading. There could be poor maintenance on a bridge, it could have a poor rating, and we need to monitor that. We can also monitor the traffic for frequency and load. I think it's important to go over the difference between static and dynamic sensors because a lot of people don't understand the true difference between a static sensor and a dynamic sensor. So as you can see, the bridge on the right side, this is a bridge that is collapsing, but there is a visible change. And that is static monitoring. You are installing a sensor and you're watching that bridge. And when that bridge has a change, whatever the change may be, in this case, it's a severe change because the bridge has collapsed. but that static sensor will show you when that bridge moves. And then you have to work backwards. So in the center, the bridge in the center, you can see the cracks were forming. So you have to investigate and find out what significant event caused that change in the bridge, that static change that was picked up by the sensors, or perhaps you can see the visible change. And in the case of the bridge in Pittsburgh, the bridge collapsed, and I believe they're still investigating what actually caused the collapse. You know, was it the temperature? Did they not perform the testing that they need to? Was it an oversized load? Whatever that may be, you have to investigate to find out what caused that. On the left side, dynamic sensors are actually monitoring the behavior and state of the structure. You're understanding how the structure is performing on an everyday basis and over time, and you're able to understand if something is changing within that structure before there's actually a visible change. So before you pick up that change on a static sensor. And that is the value in move solutions. We can take those predictive indicators of the structure and predict the physical change. And then you can prioritize your resources, focus your investigation, and reduce the overall cost, because you can take the corrective action that you need to take before there's that visible change. I'm sure we all know that it is much easier, safer, more cost-effective to fix a bridge rather than rebuilding a bridge after it collapses. The system operation. So how do our sensors work? As you can see, one of our sensors attached to a cable stay on the left-hand side. So you install the sensor. After the installation of the sensor, it is immediately possible to start the data acquisition. All of our sensors are plug and play. They communicate with the LoRaWAN gateway that we have. The sensors automatically find the gateway, so you are not trying to connect them manually. There's a watchdog system that finds the sensor immediately, and it starts the data acquisition. That data is then processed from the gateway to the cloud servers via the cellular communication. Then it is analyzed, processed, and finally displayed on our cloud platform. Finally, the data can be viewed through the appropriate cloud platform provided by us. With the platform, it is possible to manage the entire system remotely and constantly. As I said before, all of our sensors are wireless, and because they use that LoRaWAN communication system, you can receive and send data up to 2.5 miles away from your sensors. And the LoRaWAN communication actually uses very low power, so that gives you a long-lasting battery. So depending on the sensor, it could, if it's a static sensor, you get a longer battery life, or a dynamic sensor, you get a lower battery life. But depending on the sensor and the thresholds that you set, you can get anywhere from 2 years up to 8 years of battery life. And the installation is easy. There's no wiring for communication, which keeps the cost of installation very, very low. So here is an overview of our sensors. As I mentioned, we only have 4 sensors right now. We have 1 static sensor, which is the tilt meter, and then we have 3 dynamic sensors. The accelerometer and the DEX sensors are used for structural health monitoring, whereas the PPV vibrometer is used for vibration monitoring. It's great for construction sites. We have 3 communication devices. We have our analog and digital nodes, which is a way to connect third-party sensors into our system. And then, as I said before, we have the gateway, which is how our sensors communicate. Getting into the first sensor, so we have the tilt meter. I'm sure a lot of you are familiar with the tilt meter. Maybe you have used them before, but the tilt meter measures the angle of inclination at the point of where it is installed with incredible accuracy and resolutions. So things that you can do with the tilt meter for bridge monitoring. You can perform static load tests. You can find the angular variations of pillars, shoulder angular variations, the deck angular variations. And we've actually developed an algorithm that makes it independent of mounting errors. So it's extremely easy to mount this tilt. You can use the algorithm in our dashboard to make sure you do not have any mounting errors. It has an integrated temperature sensor, and this can last up to 8 years with the battery life. It's IP67 waterproof rating, and as I mentioned, it's extremely accurate. The firmware is also remotely upgradable over the air via the gateway. So this reduces the cost of visits. So say you need to update the tilt meter, you do not need to go out to your bridge, take it off, upgrade it, go back, reinstall it. You can simply do that via the cloud. Next, we have the deck sensor. So this is actually a patented technology by Move Solutions, and it was specifically designed to monitor the health of bridges. It's a wireless sensor that measures the dynamic displacement with an accuracy of 0.01 millimeters in the vibration frequency. You can remotely set a threshold. It has an integrated temperature sensor, and it also has a long battery life. This is our deck compared to a radar. And the reason that we're comparing our deck to a radar is an extremely accurate way to measure the dynamic displacement of a structure. As you can see, hopefully you can see it's not too small. The blue line is the deck and the red line is the radar. You can see how close they are. And the main reason for comparing these two is to show you how accurate the deck is. Also, the radar is about a $200,000 piece of equipment, and the deck is around a $2,000 piece of equipment. So it's extremely cost effective to measure that dynamic displacement of your bridge. Next, we have the accelerometer. So the Move accelerometer can measure the acceleration of the point where it is installed with high resolution. And our accelerometer can actually be perfectly synchronized to each other. So using a group of accelerometers, say at least 4, you can actually synchronize them together and carry out a model analysis of the structure. And finally, we have the vibrometer. So as I mentioned earlier, this isn't typically used for structural health monitoring. This is able to measure the velocity of the point where it is installed, providing a complete analysis of the frequency and amplitude of the vibration. So you can perform a real-time and remote vibrational analysis. It's a PPV vibrometer, so you can actually set the standards based on the country that you live in to measure the PPV. And this is going to help you understand if the vibrations and stresses caused by construction sites are affecting structures around it. So perhaps you are doing work on your bridge and you need to know if the vibrations are going to affect the structure of that bridge, or perhaps there's construction next to your bridge and you want to make sure that the vibrations from that construction site are not going to affect your bridge. This is the perfect tool to do so. It's, once again, it's battery powered, it's wireless, and it's super easy to install. Next, we have the analog and digital nodes. So these are a way to connect third-party sensors into the system. So you can use wireless third-party probes. So say crack meters, temperature sensors, strain gauges, whatever it may be, you can integrate it into the system by using the node. So you simply plug the probe into the node, it becomes wireless, and then it communicates through the gateway, and you can get the data on our cloud platform. The analog node has 4 channels, so it can support up to 4 sensors. And the digital node has 1 mode bus and can support up to 30 sensors. Finally, we have the gateway. So as I mentioned earlier, this is how the sensors are communicating to the cloud platform. It uses a SIM card. So you simply install a SIM card inside, If you have a bridge that perhaps doesn't have cellular service, but has an Ethernet line, you can simply plug that Ethernet line into the gateway and use it that way. As I mentioned, it has a watchdog system, so you don't have to try to configure the sensors to your gateway. It will find the sensors automatically. It is constantly looking for them. So say if you have an installation and you want to add more sensors onto the bridge after the fact, it's very easy to do so. You simply install those sensors. It will automatically find that gateway. So getting into the solutions for bridge monitoring. As I'm sure everyone is aware, there are many challenges with monitoring bridges. There are various types of bridges, and each type of bridge has problems that must be taken into account. And we offer the solution for you to do so. So some solutions that we offer to monitor the bridges are high precision dynamic movement detection for traffic fluctuations in traffic mapping, identification of the fastest moving component, and by using our tilt meters and our static monitoring, you can obtain the deflection of the structure, starting from the inclination angles to identify the component that moves slower and the result of longer pressures over time. And what are the benefits? The benefits are detection of degradation and allowing you to advance maintenance planning. So I think that's the main topic here is to plan your maintenance in advance. We want to stop trying to fix bridges once they are so far gone or once they've collapsed. These tools offer you the option of understanding that the bridge is not doing well, it's performing poorly, and that you can prioritize your resources and focus on the bridges that need the most work. And as I mentioned earlier, there are so many types of bridges, and each bridge has its own specific problem. But in all of them, we can apply analysis in the short term and long-term monitoring. So what can I do with Move systems? As I mentioned, we have tools for short-term and for long-term monitoring. So in the short term, we can perform static load tests and peak analysis and monitor all of the significant parameters of the structure, such as accelerations, dynamic displacements, and rotations. And that gives you the ability to intervene when a certain alarm threshold is exceeded. With the long-term monitoring, you can perform model analysis, and that's monitoring of model parameters such as frequencies and model shapes. So going into the short-term monitoring, one of the tools that we offer you on our dashboard is static load test. So the use of tilt meters, typically at least 4, could be 6, it could be more, allows you to indirectly determine the static deformation and consequently the maximum aero of the beams of the deck during a load test. It's very easy because you can simply install these sensors. You can use your iPad, you can be at home, it doesn't matter. And you can see in the bottom left-hand corner, this is what it would look like on the dashboard after performing a load test. And this is a tool that is so easy because typically you would have to take the measurements, use another software, input all of those measurements from the load test that you did, and calculate how it performed. This takes all of that work out of it because it's simply all in one place for you. The peak analysis in the short-term monitoring. So short-term monitoring records an event when the threshold is surpassed. So you can see on the bottom right-hand corner, those are all of the events. You can set the thresholds on your sensors. So every time there's an event and that threshold is surpassed, it will give you the event set there and also alert you that the threshold has been surpassed. And that gives you an early warning. And that is what the displacement trend on that graph is showing you, is that peak analysis. You can perform the peak analysis with our accelerometers, tilt meters, decks, and also if you have any third-party sensors, you can integrate those into the nodes. As you can see in the upper right-hand corner, this is what a complete configuration of a bridge would typically look like. You would install those sensors in the center of the span, and then depth sensors on the other spans. What is model analysis? So getting into the long-term monitoring, I want to talk about what is model analysis and why is it done? So model analysis is the study of the dynamic behavior of a structure when it is left free to vibrate. And with model analysis, it is possible to derive frequencies, model shaping, and damping. Because they depend on the mass and the stiffness that identifies each structure, you are able to find the identity card of the structure. We use the model analysis OMA. So what is OMA? So OMA is Operation Model Analysis Algorithm. So as you can see, the truck going over that bridge, we do not know the force of the system, which in this case is the truck. But since it excites the main frequencies of the structure in the same way, the result is unaltered using the FDD algorithm and eliminating that white noise. So it doesn't matter if it's a truck or a car or a bus, whatever is passing over that is going to have the same, it's going to excite the main frequencies of the structure the same way. And how can I use these parameters? So if you are using these parameters and the model parameters extrapolated from monitoring equal the model parameters extrapolated from the calculation model over time, then you know that there is no problem with the bridge. The bridge is not performing poorly. It is in good condition. There's no change in the bridge. But if the parameters extrapolated from monitoring don't equal the parameters extrapolated from the calculation model over time, then that's when you know that there's something changing within that bridge. And that's when you want to take the action. Here is another example of a complete configuration of bridge monitoring. So in this case, the depth sensors and the accelerometers are installed in the center of the span. And what those can do is detect the amplitude of the vertical dynamic oscillation, the maximum acceleration on 3 axes, the model frequency, and the temperature. And by using 6 tilt meters, you are able to understand the angular variation, the bending and the load test of the bridge, or the estimated flexion during normal bridge operation. Here is an example of model analysis, which is the long-term monitoring. So in this case, we used 4 accelerometers in the center and 2 depth sensors in the center of the span. And this is the study of the dynamic behavior of the structure. So you can use the model analysis to understand the frequencies, model shape, and damping, and get the identity card of that structure. Here is what the peak analysis in long time monitoring looks like. So we are recording the events every day and using the peak analysis to see the trend over time. So as you can see, that's the trend over time, and that's how you're going to perform the long-term analysis of the bridge. And as I mentioned, you would put the configuration of all the sensors in the center of the bridge, and then you would add depth sensors to the other spans because you don't need the full configuration over the full bridge because the load that is passing over is consistent. Here is what the dynamic displacement trend looks like on our cloud platform as well. This trend is very important because it tells us how the structure is reacting over time. Its non-constant trend over time may mean that the above loads have increased or decreased, or that there's a change in the structural parameters and that structure is responding poorly. So why is it important to do both dynamic and static monitoring? I know we've touched on this before, but dynamic monitoring gives you the dynamic identification of the structure. So that is the frequencies, the shapes, the damping, and the identity card of the structure. And that depends on the geometric parameters of the structure. And that'll give you the variation of geometrical parameters. So perhaps there's cracks, there's settlements, inclinations of the structure leading to a variation of the parameters. And that is going to show you that before it picks it up on the static monitoring, and understanding the cause of why that bridge is degrading. Why are there cracks forming? Why is it settling? The MoveCloud platform offers multiple types of raw data visualization, but above all, it offers specific tools designed to monitor your structure. So as I mentioned, we have tools for static load tests and multiple algorithms to understand the data that you are getting from the sensors. We're not just giving you the raw data and then you have to try to figure out what's happening. We're making it as easy as possible with our cloud platform. As you can see on the picture, you can upload your own photo of the bridge that you're monitoring, and you can insert all of the sensors that you have on that bridge. So as you can see all of the sensors. Next to it is a green dot, which means that the sensors are online. As soon as the sensor goes offline, you will see a red dot. So perhaps the battery has died, perhaps it got knocked off of the structure for some reason, perhaps something hit into it. You'll be able to see that right on your cloud platform, which ones are online and offline. You are also able to freely configure all of your sensors. So if you need to set thresholds or different parameters on your sensors, you do not need to ask us to do so. You can simply get onto the cloud platform and use the tools that you need to and configure all of your sensors freely. We also offer technical support, and you have access to all historical data. Here is an example from the cloud platform of frequencies of the structure and what model shaping of the structure would look like. Using our dashboard, user experience is essential to Move solutions. So this is why it has been specifically designed to help understand the data and keep it simple and intuitive. As I mentioned, it's possible to customize and manage the display of the installed sensors, upload your photographs. You could put technical drawings in there. You can also extrapolate the raw data as well. So it is possible to access and analyze all of the historical data detected by the sensors, compare and correlate them with each other. Through the analysis of the raw data, it is possible to understand the trend of the state of health over time of the monitored structure. And as I mentioned, there's tools for every type of structure. So we don't just do bridge monitoring, there's tools for many types of structures. So perhaps you have a rail track over a bridge. You can install the sensors and use the tools for both the rail and the bridge. Here is what it looks like using the vibrometer. So I haven't talked a lot about the vibrometer since I first mentioned it. But as you can see on this chart, you can actually set a threshold with the vibrometer. So with the use of vibrometers, both in the sites under construction and in neighboring buildings, it's possible to monitor how the structure reacts to these stresses and whether or not they are harmful to it and users who use it. So you can simply, if you look at the scatter plot, say if you're using one of the standards, the USA standard or a European standard, you can set that standard right into that scatter plot. Now, every time there's an event, you'll see the dot. And if it's below the threshold of vibration, so it's safe, you'll see it below the line. Now, if it goes above the threshold, so the vibrations are becoming unsafe, you'll see it above the line in red, and it will also alert you immediately that there is a problem and you are able to call the construction site, go to the construction site, find out what's causing the issue. Looking at the two types of analysis in detail from this installation, for example, the decks installed in the center of the span allow you to directly monitor the dynamic oscillation of the deck in millimeters. Any event that exceeds a certain threshold set by the user is logged. And every day, all of these events are taken, and in the platform, this trend is displayed, significant of how the structure reacts to traffic. This analysis can be done not only for dynamic sensors, but also for all of the sensors. And that's all I have for you. I think I finished up a little early. So if you have any questions, please put them in the chat. Okay, so Vincent, what is the battery life of the vibration monitor and what's the temperature range of these products? So the battery life of the vibration monitor is about 1 year to 2 years. And what is the temperature range of these products? Let me check. I don't know exactly. I'm not 100% sure what the temperature range is, but that's certainly something I can find out for you. Are the data sent from sensors to gateway in 100 hertz? So I'm not sure particularly what that question is asking. So I will have to get back to you on that too. Sensors sent to the gateway. Oh, I got the answer for the temperature range. So it is -40 degrees Celsius up to 60 degrees Celsius. And let's see if I can get the answer for the gateway. Oh, if you're asking how many can be connected to the gateway, you can actually connect up to 40 sensors to the gateway. Does anyone else have any other questions? Let's check in the chat. Oh, I think there's someone here. Okay, so the volume kind of low, just wondering if it's from me. Oh, I hope everyone could hear me okay. How many sensors per gateway? Up to 40 sensors. What is the preferred distance between sensors? So the distance between sensors typically depends on the installation and what you are typically trying to do. But from the sensors to the gateway, up to 4 kilometers or 2.5 miles. Would you use the same approach as your examples for a new bridge structure to monitor and plan long-term maintenance? Yes, you definitely could. I know with new structures, it's common, well, I'm pretty sure with all new bridges, you have to perform the load test. So that would be a great example of you could perform the load tests and then keep the sensors on there to monitor the long-term health of that bridge. How frequently would you take readings in this case? So it would depend on what your goal is. You can set the parameters in the dashboard. So it's completely up to you, and it really depends on what you are trying to do over time. In the example of the bridge monitoring in Italy, at the end of the presentation, we see railway tracks. How is LoRa transmission and in general, the functioning of the sensor and nodes influenced by electromagnetic interference? So the LoRa transmission with the direct line of sight would be up to 4 kilometers or 2.5 miles. So if, yes, you do have a lot of interference between that, we do have the option of adding a longer range antenna to the gateway if you need to, or you could perhaps try to get that gateway closer to the sensors, but we do have the option of upgrading that antenna. Will the presentation or recording be shared? Yes, absolutely. We will send you the recording. What is the frequency of the accelerometer reading? So you can set the frequency. You can set the frequency in the dashboard. So you can take readings. I believe it's I don't know the exact readings in the dashboard, but you could do say every 2 minutes, every 10 minutes, every 20 minutes, every hour. So you can actually set that in the dashboard. To the question about greater than 100 hertz, I think I can clarify. Continuously streaming data at hundreds of hertz over radio will deplete batteries very fast. So either the nodes compute summary value and frequency peak position and transmit only that, or waveforms are only transmitted under certain conditions. Can you clarify exactly what data is available at the gateway? I believe I can. Let me check on that. Oh, and what is the frequency of the accelerometer reading? I think too, also the frequency, it can go from 40 hertz to 80 hertz to 120 hertz up to 640 hertz. And I'm going to have to get clarification on your question, Vincent. I'm so sorry. Just a moment. Okay, so I got the answer for you, Vincent, I think. So it's a static sensor, so they only send one data, which is the mean value over a certain amount of time of sampling. So it would sample for a certain amount of time and then send that mean value over the gateway. Let me know if that answers your question. Perfect. Okay, and then if there are any other questions, you can put them now, or you can email them to info@movesolutions.it, and we can answer any questions for you. Let me check back in here. Okay, perfect. So thank you so much for coming to my webinar today. I loved presenting it to you. Like I said, if you have any questions, just email them to info@movesolutions.it. Thanks again, and I hope you guys have a great rest of your day.